When you are ready to begin the presentation, press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. We're going to start today's session. So in today's session, we're going to start with the architecture of SAP HANA. I'll log into the system. You first log into HANA Studio. So once we double click on the system, here you see landscape. Click on the landscape. So once you click on the landscape, here you would see index server, name server, preprocessor server, a statistic server. So all these are different services in SAP HANA. HANA can be configured, please see, HANA can be configured as a single host configuration, or it can be a multi-node cluster configuration. So how these services are running when you have a single node and when you have multi-node cluster configuration. Let me show you. So one is index server, preprocessor server, name server, statistic server, access engine, SAP host agent, SAP solution manager, the SAP Hana Studio repository, the last is software update manager. And here you have shared persistency layer. So in a distributed landscape, on side you have node 2, this is multi-node cluster configuration. So in here you have index server, same preprocessor server, name server, SAP host agent. So in the same way, and it moves on. And how many node you want, you can configure. So first of all, Enterprise applications that want to have both master data, transaction data, structured, semi-structured, all this kind of data can be handled inside the HANA DB. Data is being written and updated into the DB for both transactional and analytical data. We also know HANA stores data in columnar storage, has multiple CPU, and it has large main memories. HANA consists of different servers. Index server is the most important one. And the other servers are name server, preprocessor server, statistic server, access engine. So what is the use of index server? This server holds the actual data and the engines for processing the data. So whatever the data that we have in tables, the data is processed by index server. When SQL or MDX queries are fired against SAP HANA system, the first it does is it authenticates the session. It does the authentication, the user ID, password. And transactions, index server takes care of these commands and process them. The incoming SQL and MDX statements. Name server holds the complete information about system landscape. What components are running on what nodes. Name server has the complete information about the landscape. Name server is responsible for the topology of SAP HANA system. In a distributed landscape, SAP HANA instances will be running on multiple hosts. In this kind of setup, name server knows each component running on different services, different servers. Preprocessor server. This server comes into picture when you want to use text data analysis, text data, semi-structured data. Index server utilizes the capabilities of preprocessor server in text data analysis and searching. This helps to extract information on which the text capabilities are based on. Statistic server. This server helps to collect data for system monitor and helps us to know the health of SAP HANA system. A statistic server is responsible for collecting data related to status, resources, consumption of CPU, performance of SAP HANA system. So all this is taken care by statistic server. We can also monitor various alerts, alert monitoring. Here you have alerts. So you can also do alert monitoring. For example, if there are two alerts in high priority, show alerts. So these are the alerts. So monitoring status of various alert monitors requires data collected by statistic server. Access engine. Access engine allows external application developers to access SAP HANA system via Access Engine clients. For example, a web browser accesses SAP HANA application built by application developer by using HTTP protocol. Application developers built applications by using Access Engine. The persistency model in SAP HANA database is converted to a consumption model for clients to access via HTTP connection. It allows organizations to host system services that are part of SAP HANA database. What is SAP HANA host agent? Host agent should be installed on all the machines that are running on SAP landscape. It is used by a controller known as Adaptive Computing Controller. This is to manage system and software update manager for automatic updates. LM structure. LM structure for SAP HANA contains the information about current installation details. So inside the host agent you also have LM structure. So this LM structure is responsible containing information about current installation details, information about some like automatic updates. Solution manager. A solution manager diagnostic agent. This agent provides all data to solution manager, SAP Solman, to monitor SAP HANA system. After the solution manager is integrated with SAP HANA system, this agent provides information about database at one glance, which includes the database state, general information about system such as alerts, CPU, memory, disk usage. SAP HANA Studio Repository Manager. Repository. This helps the end users to update SAP HANA Studio to higher version whenever a version is changed. SAP HANA Studio Repository is the code that does this process. Software Update Manager. This helps to automatic updates of SAP HANA from the SAP Service Marketplace and patching the SAP host agent. It also allows distribution of Studio repository to the end user. Now let us see more details about different components that are inside the SAP HANA DB. I mean, in each component, details about each component. Not sure if I can get some. Let me try to get some diagram in Google. Time. Excuse me. So first, storing of data. So this architecture diagram of SAP HANA has mainly there two engines of how data is stored. As we know, row store and column store. These relational engines are in memory, meaning that the primary way to store data is always on RAM. Row store stores data in rows, just like a traditional RDBMS, but it resides in memory. Row store engine is highly optimized for write operations, writing of data. All the operations on row tables will be processed by this row engine. When a query is fired on top of SAP HANA DB, first the optimizer decides. So there is an optimizer that decides which engine query has to be executed. Because inside the index server, you have multiple engines. So who is going to decide? Optimizer. Question will come in certification. Question comes in certification. When a query is fired on SAP HANA DB, who decides? Optimizer decides. Optimizer. For example, there may be many functions that OLAP engine doesn't support. But the row engine, in that case, the optimizer sends all the data to the row engine and gets the task done in the row engine. This may be more time consuming as the column data has to be converted to a row data before it is processed by a row engine. So one such example is mainly that is used by non-equi joins will be executed by the row engine, and this is not supported by column engines. So non-equi joins are executed only on the row engine and not supported by the column engine. Non-equi joins will be supported only by row engine and not supported by column engine. Please highlight this point. Now, if you see here, you see there is different components inside the SAP HANA DB. First is the Transactional Manager. So, in the Transaction Manager, and in transactional, a request is sent from the Transaction Manager, and the communication is happening to transactional version management, transactional version memory. This memory section holds temporary version of data. All the recent versions of changed records are maintained in this section. Transactional version memory. All the changes are maintained in this section. This data is required for multi-version concurrency control. SAP HANA implements multi-version concurrency control to provide concurrent access to the database. Data reading and writing all happens in parallel. When the data is being written by some users and some users are reading the same data, so what is going to happen? It gets locked. And data becomes inconsistent. To avoid this, technique such as locking, MVCC is implemented, multi-version concurrency control. Locking is an effective way for handling concurrency problems. However, MVCC is very effective in handling the latest version of data. When a query hits the database, the data at that time is displayed. The changes made will not be reflected in results unless and until the transaction is committed to database. When there is any new set of data that is uploaded, MVCC will not update old data. It marks the old data as outdated and writes new set of data elsewhere. So that's why HANA is known as insert only. Insert only. Old data is discarded and only new data is considered. In this process, there will be many versions of data stored, only being the latest version. Hence, a considerable amount of memory is required to maintain these data versions. MVCC is a combination of time travel mechanism, allows temporal queries inside the relational engine. So over the period of time, how the data is being changed, you can see via MVCC. Segments contain actual data from different pages. All the data in the row store tables are stored in segments in the form of pages. Just like a book has pages, all the row stored data is stored in the form of page. The concept of linked list is used to storing these memory pages. Linked list is one of the fundamental data structures. The SAP HANA database uses the same row stored tables, a linked list of memory pages. All these pages are grouped into segments. The typical size of each page is 16 KB. Each page is about 16 KB. Page Manager. Page Manager is responsible for memory allocation. It also keeps track of used pages and free pages available. Version memory consolidation. As we discussed just now, different versions of database are stored in the transactional version memory. MVCC takes place of this data consistency. When a transaction is committed, it has to be stored in the database table. A row table in this version memory consolidation takes care of this activity. The recent versions of changed records are moved from transaction version memory to the persistent segment on the commit ID. After moving all the recent versions to the persistency segment, the temporary data and the different versions created by MVCC have to be cleared from transactional version memory for effective usage or for effective utilization of the memory. This activity is also taken care by version memory. Version memory consolidation can be considered as a garbage collector for MVCC. Persistency layer. Persistency layer is used for writing purpose. It is used for writing purpose. It is also called in log write operations and checkpoints. All the database logs are maintained by log reply undo agent. So this is the persistency layer. Log volume size, data volume size, trace volume size. All database logs are maintained by log replay and undo agent. After the data has been reloaded into data area of database, it will replay the log from log backups and log area. After the data has been reloaded into a data area of database, it will replay the log from log backups and log area. The database will be back online only after these actions are completed. The redo log information is located in log backup and log area of the database. The recovery process takes care of checking log positions in data backup after data area has been restored. In order to replay the logs, the log position must be available either in the log backup or in the log area. The system should find offset on if backup is being used for recovery is not the latest one. We must ensure that offset needed for backup is available in log backups and log area. Unless the required offset is present, log replay cannot be preferred during recovery. If the system cannot find the log offset in the log area, we can see an error message. Log and data must be compatible. In this error situation, we must clear log options to get the system online again. Any logs in log area are ignored during the log replay. Even if the replay of the log area is not performed, the system ends up in a consistent data stage. The data area holds all the undo log information, and it is reloaded into area during the recovery. The replication server won't have to restart point if log replay has not taken care when the situation occurs. If we perform a recovery without log replay, the log area is format, the log backups are replayed, but not the logs in the log area. In this situation, the .ini files can be recovered, and the recovery is not important. If the INI files are recovered, parameter changes made by backup will not be recovered, therefore they are lost. When we clear a log position, the data changes made by data backup will be lost as log entries gets cleared from system. The transactions that are not yet committed in the backup will be rolled back, undo. Only when log replay of the log area cannot take the log option has to be used as an exception. So the following are the situations when a log replay may not be possible. So there are three situations. Number one, when the log area is corrupted and the log information is not longer available. Number two, log backup is missing, which links the latest available log, backup of the log area. Number three, while performing a disaster recovery, is a log available in the log backups and the log in the log area are not compatible. Write operations. Write operations, when there are any write operations, they mainly go to the transaction version memory. Hence, all versions are maintained by MVCC and finally written to the persisted. The insert operation also writes data to the persisted segment. What is persisted segment? Persisted segment contains data that is used in the ongoing active transactions and data that has been committed before any active transaction was started. Index. Each row store table has a primary index, row ID, is a number that specifies the memory segment and the page of each record. Primary index maps primary key of the table to row ID. Row ID consists the segment address and the offset. Row ID is the number that specifies memory segment and page for each record. Primary index maps memory key of the table to the row ID. Row ID consists segment address and the offset. To locate a record, combination of segment address and segment offset is the formula that becomes segment address plus segment offset. The memory page of the table record can be a structure called as row ID contains the segment and the page of the record. When tables are loaded into memory on the system startup, indices for all the row tables are never stored permanently. We can create a secondary indexes if required. But it is not recommended. Number 1, why it is not recommended? For column it is not recommended. For row it is recommended. It is always better to create a secondary indexes for row rather than in column. It is recommended because table contain low volume of data. It is used when the application request has to access the entire row. It is used when data has to be processed record by record. Storing data in column stores. Data will be stored in memory, similar to row store. The concept of column storage has been taken from T-Rex. This technology was further developed into a full relational RDBMS. And also, a compression works well with columns and can speed up operations on columns. Column storage is optimized for high performance of reads. There are two types of indices on column storage for each column. One is the main store, the other one is the delta store. For write operations, delta store is optimized. For main store is optimized in terms of read performance. Memory consume performance issue when loading directly to a compressed column. So in the memory, there is an optimizer and executor. Optimizer gets the logical execution plan from SQL parser or the calculation engine as the input. And then it generates an optimized physical execution plan based on the database statistics. This we see in the past also. In the past we have seen how the engines exploit data. The best plan for accessing row or column stores will be determined by database optimizer. Executor basically executes the physical execution plan to allow the row and column stores and also process all the intermediate results. Next, main storage. Data is highly compressed. Delta storage. Delta storage is designed for faster writing of data. Delta merge. Write operations are only performed on delta merge. Delta merge process. In delta merge, there is a before image operation and during the merge operation. All the write operations that go to delta storage are read from the main storage. During the delta merge, when a merge operation is in progress, all the changes go into the secondary delta. So basically, during the merge and after the merge, there are different sections created by system. So why it is always better to go for a column storage? When you have huge volumes of data, when you want to use lot of aggregations, when the table have huge number of columns, when the table has to search based on values on few columns, the main advantage is parallel processing, and the number of cache cycles will be read. The small sets to help to retrieve data faster. So row store, column store, delta, before delta merge, after delta merge, SQ optimizer, executor. So these are all theoretical session, because all this is we cannot see in the system. This is internally happening inside the system. Storage and column stores, persistent segment, persistency layer, version memory consolidation, page manager, segments. So segments contain actual data. Page manager is responsible for memory allocation. Version memory consolidation. Data are stored in the transactional memory, and MVCC takes care of data consistency. Transactional version memory that holds temporary versions of data. All the recent versions of change records are maintained in this section. Executor. How to execute the query? If an incoming query is an SQL or MDX statement. So let me show you some practicals on this. So in order to take backup, right click on the system, click backup, click backup system. Once you click backup system, so as we just discussed, there are two. One is data backup and the log backup. So here you have data volume, log volume. So complete data backup, differential data backup, incremental data backup. Only the difference between the last or the complete. So we have around 45.32 GB of data to be backup. So we don't do this. So here you have destination type file or backup int. You can also backup to third-party systems. You right click on System, click Backup. You also have Recovery. You can recover from backed up files. Backup, you can see the configuration, log backup settings, destination type file. This is the destination, backup interval for every 15 minutes. Enable automatic log backup. So for every 15 minutes, there is an automatic log backup. Right click on the system, click Configuration and Monitoring, open SAP Hana Cockpit. The cockpit gives more details about the performance and health of SAP HANA system. This executes on Axis Engine. So you also have a transaction code DBA cockpit if you want to see in the application layer. This is the Axis Engine. So this is mainly used by the administrators. Double click on the system. Here we can see landscape, all the services that are running, alerts, performance of the system, all the sessions that are running in the background. These are all the sessions that are running in the background. Expensive statements, anything running in the background. SQL plan cache memory. All the plans of the SQL is stored in SQL plan cache. How many threads based on what are the top 5 users? How many number of active threads, inactive threads, volumes, what is the size of data volume, log volume for name server, index server, configuration. You want to configure SAP HANA database parameters. You have different parameters like global INI. All this is configuration by HANA admin. System information. It has all details about a data catalog, shows record logs, merge statistics, resource shows the table logs, diagnostic files, and trace configuration. You can enable database trace, SQL trace, performance trace. So this all this area is taken care by the HANA admin. So once we complete this, next we go to certification questions. So tomorrow we're going to start with the first set of questions that is based on. So I'm going to show you. So one is based on C_HANA 131, and the second one is C_HANA 151. So both these questions have approximately around 140 questions. So what we will do is because I know most of you are writing the exam next week, so I would like to complete this. We can log into session at 5:30. Please log in 30 minutes before. Please kindly log in 30 minutes before. We can log in to 5:30 and 7:30. Till 5:30 to 7:30 we can log in and we can see these questions from tomorrow. So there are 80 questions in here, and then there are the 70 to 80 questions in another 151 exam. I'm 100% sure once you get all these questions, you can clear your interview and even clear your certification. If you're thorough with all the classes and these questions, you'll clear. So 131 is the foundation for 151. So after complete 131, we can see 151 questions. So tomorrow we can start at 5:30 in 5:30 a.m. So today is Thursday. Today is Wednesday, Thursday. So Friday we can start. Tomorrow I can explain 131, and Saturday we can take 2 to 3 hour session on Saturday. Saturday can take 2 to 3 hour session. We can start from 10 to 1 a.m. Sorry, 10 to 1 means 10 a.m. IST till 1 p.m. IST. We can start on Saturday. Then we can close. And next week, and you can write exam. We can just prepare Sunday, Monday, Tuesday. I know some participants are writing an exam. You can prepare and you can write the exam. Any questions? Please ask me. Also, any guidance anyone want to take, please call me today. I can guide you more on this. 9:30 to 10:30 a.m. IST. And participant writing certification, please immediately contact me. I can guide you on questions and tell you how to. What day you are writing, please let me know. We can proceed. So this questions discussion is something like a recap of the entire subject until now what we have seen. Please book it immediately. Immediately you can book exam, no problem. Please book your exam immediately next week itself. You can clear off, no problem. The more the delay, the retention of knowledge happen. Retention when sometimes we may get busy. So immediately book it, please. Please book it immediately. We can clear it off, no problem. It's very easy. I think everyone know the code, right? C underscore Hana IMP 151. That is the latest one. C underscore Hana IMP 151. Please do attend tomorrow at 5:30 a.m. So 151 exam is the latest exam. It's the latest exam. One five one is the latest exam. Is it possible for everyone to attend evening session today? It's 7 to 8:30. 7 to 8:30 p.m. Please try to attend. We can have more time to prepare. We can have more time. Tomorrow evening also we can have, no problem. Tomorrow evening, today evening, tomorrow morning, continuously we can have. I can take it. This today evening we can have it because most of the participants okay. So I can conduct one session from 7 to 8:30, and tomorrow morning one more session we can conduct. Tomorrow evening we can conduct one more session. If time is there, we can conduct on Saturday. Otherwise, we can finish off. If it is there, we can also conduct on Saturday. So I'll just write down the time. You can write down the time here. Today's date is 2nd 6 2016, 7 p.m. to 8:30 p.m. Tomorrow 3 we can have 6 same, so we can have same time. We can have same time. Same time we can have. So 6 to 6 to 7:30. This is regular class. And tomorrow evening also. 3, 6, 2016, 7 to 8:30 p.m. IST. This is AM IST. And Saturday, if it's possible, that is 4th. So 4th is the last date. 2016. If possible, we can also extend to 10 to 12:30. 10 to 12 or 12. I mean, this is optional. This is optional, but still we can take it. If you want, we can take it. So I can recap entire sessions. We can see some issues. Wherever we are stuck, we can see some recap issues. Okay, then we'll see you tomorrow, today at 7 to 8:30 p.m. AST. Thank you, everyone. I'll see you today evening. We can start the questions.